Let's look at example 2. A tourism board in Vermont wants to compare the proportion of fall visitors who hike in two popular regions. We have the Green Mountains and the White Mountains. A random sample of 150 fall tourists in each region was surveyed. So that's telling us we got two samples and each one has 150. Notice how, before we go any further, we're talking about proportions here. So that means we're going to be dealing with the binomial distribution. When we read the information for each group or each sample, in the Green Mountains, we have 79 tourists that said they went hiking. So in this sample, we have 79 successes. Success means the person likes to go hiking in those mountains. So in the second sample for the White Mountains, we have 84 tourists said they went hiking. So X is 84 for the number of successes in the second sample. We're going to construct a 90% confidence interval to estimate the difference in the true proportions of fall tourists who hiked in the Green Mountains versus the White Mountains. Assume the samples are independent and that the conditions for inference are met. Because we're doing proportions, we want to make sure that we can estimate the binomial distribution with the normal distribution by checking to see if n times p and n times q for each of those samples are greater than or equal to 5. So our sample size is 150, so that's our n. So I would take 150 times the probability of success, which would be 79 out of 150. When I multiply that, I get something definitely bigger than 5. When I take the complement of that for the n times q, the number of successes would be 71 because that's what's left over from 79. So our probability of failure would be 71 out of 150. And when I multiply that by 150, we certainly get a number greater than 5. Now, when we do that same calculation for the second sample, it's also going to work. I'll let you practice and do that on your own. But the conditions are met here for us to be able to use a z-estimate for proportions. Now, because we're doing a difference of proportions, I'm going to choose this option here that says z-estimate, difference of proportions. We're doing a 90% confidence interval, so I'm going to put in 0.90. That was already there, so that's good. Now, for the first sample, the number of successes is 79. And that's out of 150. For the second sample, we have 84 successes out of 150. Okay, now, when we enter that, we get that our lower limit is negative 0.1279 and our upper limit is 0.0612. So let's write this down. We're doing a z-estimate for the difference of proportions. Our confidence interval that we got is negative 0.1279 and the upper limit is 0.0612. So this tells us that when I take P1 minus P2, that's going to be between 0.0612 and negative 0.1279. So if I subtract P1 minus P2 and I get a value, it could fall between one of these two numbers. But because this one's negative and this one's positive, we can't be certain if that difference is negative or positive. So I would write for my conclusion, we cannot draw any conclusions. We need to do more research and collect more data.